Hello everybody. In this video I'll talk about data warehouse. Data warehouse is a data repository basically established or constructed for data mining purpose. Data warehouse provides tools for business executives to use data to make strategic decisions. Data warehouse is described by four features which distinguish it from other data repositories: subject-oriented, non-volatile, time-variant, integrated. Data in the data warehouse are stored on specific subject like customer, product. So like in operational source, there we can find different data on different subjects. But in case of the data warehouse, the data is specifically collected on the basis on the subject on which users want to do data mining or data analysis. The data of the data warehouse is historical data, that is the past data, and we cannot change past. That means data of the data warehouse is never updated, so it is called non-volatile. Time variant. Each and every data of the data warehouse is given the notion of time. When is data collected? When is that data about? So the data will be of different time in the data warehouse, so it is called time variant. Integrated. Organization people make different decisions. Sometimes whatever data that are generated within the organization may not be sufficient to make required information and to make decision. In that case, data from other sources have to be brought and integrated with the data warehouse. So data within the data warehouse will not only contain the data of internal system but also data from other sources also. So it is integrated. Data warehousing is the process of constructing and using data warehouse. Construction of data warehouse is done through following process: data integration, data cleaning, data consolidation. Data from several sources are brought and stored within the data warehouse. There are lots of processes that have to be performed to integrate data from different sources, as data from different sources have different formats. The type of the data may be different. So in order to integrate easily, those all different format data, different type of data has to be converted into one single format. So data integration is a rigorous process within the construction of data warehouse. Data cleaning. It is possible that whatever data collected from external sources and external sources and operational database, there may be some error, redundancy, noise within the data. And we cannot use that kind of data having error, noise, redundancy for data mining or data analysis purpose. So it is necessary to make data consistent, correct, error-free, noise-free. That is, data cleaning has to be performed in the construction of data warehouse. Data consolidation. Several data has to be summarized, aggregated. In order to answer user's query efficiently, it is necessary to generate summaries. Summaries, if generated, then users can get their queries result immediately. So data consolidation is also done in the process of data warehousing. Differences between operational database systems and data warehouse. The major task of online operational database system is to perform online query processing and to ease or solve daily occurring operations of organizations. Basically, online operational database systems are established to help employees in their working, to perform their tasks and activities easily. For that purpose, online operational databases are constructed. But data warehouse OLAP systems serve knowledge workers in the data analysis and decision making tasks. So data warehouse OLAP system will have the complicated modules which will enable knowledge workers, data analysts to get information, data of their requirement. Now let's talk about the basic differences between OLTP and OLAP. First is users and system orientation. OLTP is basically customer focused. OLAP is market oriented. OLTP is constructed to help employees and customers in daily occurring tasks, but OLAP is developed to help decision makers such that they can make different strategies, such that they can have better marketing opportunity, such that they have better competitive advantage in the market. Data content. OLTP uses current data, but OLAP uses historical data. Database design. OLTP database is based on entity relationship model, but OLAP systems are based on star schema or snowflake schema. View. OLTP uses the current data that exists within the organization, but OLAP uses historical data and it also considers data from different sources. Access pattern. Basically, short atomic transactions are performed in OLTP. Means the transactions which are of type updating the data, where concurrency control has to be considered to make the data consistent. But in case of OLAP, only read-only operations are performed. OLAP systems are used for decision making, so it will have the historical data and we are not supposed to change the history by updating the past data. So OLAP systems stores only read-only operations. Why we need a separate data warehouse? The major source of the data is operational systems. We are having data already in the operational systems. Again, why we need the separate data warehouse? Why cannot we perform online processing directly on operational databases? An operational database is designed and tuned for sourcing particular records, but data warehouse queries are complex in nature, which involve computation of large groups of data at summarized levels. Operation sources are developed to ease the daily occurring tasks and activities, but that is not the idea behind data warehouse. Data warehouse produces the information. It will provide a different kind of pattern to the data analyst using the data mining algorithm, data analysis algorithms for the long-term decision-making processes, for making unstructured decisions, to handle unstructured, semi-structured decisions. Operational data may contain noise, error, redundancies. OLAPs are data mining tools need correct, consistent, reliable data. In the organizations, it may not be necessary that data should be consistent. They require only those data which are necessary to perform their daily occurring tasks. So it is very possible that operational data contain noise, error, and repetition of the same data. But OLAP systems, data mining tools need consistent, reliable data so that they can generate reliable information. We cannot generate reliable information from unreliable, inconsistent data. The structure of operational database is not suitable for addressing decision support queries requiring historical data. Operational databases, operational systems are basically constructed by considering to help customers, employees in their daily occurring tasks and activities. But they may not be suitable for making big decisions or unstructured decisions. So we need a separate data warehouse where data from the operational sources are collected, pre-processed, means these noise, error, redundancies are removed. Data from other sources are brought and uploaded or stored within the data warehouse. We cannot directly work on operational system. Operational systems have certain problem. They are designed to address certain particular issue that occur daily. So we need a separate data warehouse. In this example, I have shown you the inconsistency within the data. Here you can see the age is missing. Age is missing here. This is the missing value. In the operational system, that is very possible. Organization may not need this detailed information sometimes. Operational source system may work without having full correct data. Here another we can see inconsistency. Here gender is specified by yum, but here it is male. Similarly, here gender is written only yaf, here female is written. So system will not understand that yum and male is same. Similarly, here the spelling of Kathmandu and here are different. So this kind of inconsistency is very possible with our operation source systems, and we cannot use this data for data mining purpose. So we need a separate data warehouse where we will be populating data from the operation source system, but that data will be pre-processed. Those data will be made consistent. Redundancies, inconsistencies, noises are removed using different techniques, different data pre-processing techniques. Then only those corrected consistent data will be uploaded to the data warehouse. So because of this problem within the operational source system, and because of the nature of the operational source system, we need a separate data warehouse to perform our data mining task. Data cube. Data cube is a representation of the data. Data cube consists of dimensions and facts. Dimensions are perspective or entities about which organization collect data. Time, item, branch, location, suppliers, customers are examples of dimensions. Dimensions are like entities of the transactional database. Each dimension is represented in the data warehouse by dimension table. Facts are numerical values. They are quantities by which organizations want to analyze relationship between dimensions. Fact table contains name of the fact or measures and keys to each related dimensions. Fact are actually the summarized values. For example, if the department store manager wanted to know, okay, what is the sales in the last week in particular area, maybe New Vanisher. In that case, that manager needs the summarized value, one single value that is summarized on the basis of time, that is the last week, and the location, Baneswar. So facts are numerical values that are summarized using different dimensions. And this data cube will contain data about dimensions that are entities or subject about which we want or data miners want to analyze the data. Customer, product, supplies, brand, location, etc. are dimensions. And data analyst managers of the organization would like to know summary informations based on these dimensions like suppliers, customers, products, time. Data cube is a metaphor for multi-dimensional data storage. Data cubes can be of any dimension. Cube, it doesn't mean it should be of only 3 dimensions. It can be of 2 dimensions, 1 dimension, or more than 3 dimensions. It is only a metaphor. Data cube showing data in different degree of summarization is called cuboid. We can generate data cube based on 1 dimension, like only on the basis of time, or we may consider data cube generation using time, location, product, customer. 4 different dimensions we are using. That means data can be shown in different degree of summarizations. What are the dimensions we are considering? And in case of the dimension, there may be other attributes on the basis of which we can generate different summaries, aggregate tables. So it is necessary to understand that data cube can be generated on different degree of summarizations. And we know that entity relationship diagrams are used to create relational database that are used for transactional databases. But to create data warehouse, we will be using multi-dimensional data model. The most common modeling tool for data warehouse is star schema. It consists of large central table known as fact table and a set of smaller tables known as dimension table. Here in the picture we can see simple example of star schema. It consists of 4 dimensions: customer, product, location, time. And the central table is known as fact table. It contains the summarized value. Here the total cell, that is the summarized value on the basis of customer ID, product ID, location ID, and time ID. These IDs are related with this primary key of these dimensions. In this case, CID is dependent on CID of customer, PID is dependent on product ID of product. In this way, we can create the star schema. But sometimes in the star schema, we can see dimensions be normalized. For example, there is one entity within this product. Some attribute that attribute represents entity. In that case, that entity will be represented by another dimension, and that dimension's ID will be written here. So if the product or some dimensions are normalized, then that schema will become snowflake schema. And in case of the fact constellations, we will be finding more than 1 dimensions. In case of the star schema, there will be only 1 dimensions. Group by clause of relational database queries are used to create measures or fact. Concept hierarchy. Concept hierarchy is the model of different levels that a dimension can be mapped to. For example, time dimension will have year, quarter, month, day, week, etc. as different labels, and data given in one label, for example day, that can be summarized on month, week, year, quarter. That means data given in one label can be summarized into another label. That is the basic idea behind the concept hierarchy. We will be seeing use of the concept hierarchy in OLAP operations. In case of drill up, from going from low level to higher level, that is the drill up. There we can see the use of concept hierarchy of different dimensions. Now let's talk of types of OLAP systems. Online analytical processing. Relational OLAP server. Relational OLAP server lies between relational backend server and client front-end tools. Relational or extended relational DBMS are used to store and manage data warehouse. Basically, in case of the relational OLAP, OLAP servers are used. They're really the database developed in the relational database like MySQL, MS SQL Server, Oracle, etc. And they're really client front-end tools like web browsers or Java Swing components or some other user interfaces. In between, we will be seeing the relational OLAP servers. OLAP acts like a middleware to support the missing pieces. That means OLAP will be helping to connect user interface, that the client front end, and the relational database, that is the back end. That is the basic idea behind the relational OLAP. Relational OLAP does optimization of each DBMS backend, means it will help to execute queries easily. Implementation of navigation logic also enabled by OLAP systems. There is another type of OLAP, that is the multi-dimensional OLAP server. These servers help to view data in multiple dimensions using array-based multi-dimensional storage engine. Multi-dimensional array, which we see in different programming languages, that kind of constructs are used. OLAP operations. Drill down, drill up, slice and dice, pivoting are the OLAP operations. To illustrate these operations, I have considered a simple database table consisting records of customers, name of customer, their address is provided, gender, hobby, name are also provided in this table. Here in this table we can see the address or location of customer are given in different levels. First is place name, then district, then province. These different levels of the location or address are part of concept of this address or location. Address or location can be seen in different levels. In this case, place is in the lowest level, province is in the highest level. So if the data is given in the place, then we can aggregate that record on the basis of district or province. So here I have created a simple summary table showing number of records by each district. Here district is also given. Similarly, here another table is given where records are summarized on the basis of province. We can see how many people belong to a specific district, and we can also know how many customers are from certain province. So using the concept of concept hierarchy, we can map low level concept to high level concepts, and the process of going from low level to high level is called drill up. We are drilling up in the concept hierarchy. So what in the reverse, what you can do is we can see the data given in province to the low level, because we can summarize the data by place name also. We can descend in the concept hierarchy from high level concept to low level concepts. That process is called drill down. Drill down means we will come down from the high level concept to the low level concepts. Here I have considered the location. Location can have different levels. Similarly, time dimension can also be divided into different levels like day, week, month, quarter, year. So data given in different levels can be summarized or mapped to higher level. So in this way we can perform drill down, drill up operation using the concept hierarchy. So how many products are sold in specific location in specific. This is a number or total sales of certain products. If P1 is the product, the first record says P1 is sold in 200 numbers in location 1 in time 1. Location 1 is Baneshwar, Kathmandu, and similar time 1 is 2023 first month, first day. Similarly, product P1 is short, used in winter, its cost is 1600 rupees. So this sales fact table can be sliced, means we will be considering single dimension to see the data. So here I have created a slice of sales fact. Slice operation considers only one dimensions to show the data. Here I have used only time dimensions. On the basis of time dimensions, I have shown this total sales. Similarly, dice is operation is considering more than one dimensions. Here in this table you can see I've considered two dimensions, that is time and product, and numbers total sales are shown on the basis of time and product. In this way, we can use slice and dice operations on that fact table, and slice and dice operations are part of OLAP operations. Similarly, pivoting is the process of moving or rotating the cube. Cube have 6 faces, we know, if we consider only 3 dimensions. In that case, cube will have only 6 faces, and that 6 faces can be rotated on some pivot. That rotating the that cube is known as pivoting. One face will be showing one data and another face will be showing another summarized data. Similarly, 6 different faces will be 6 different summaries. So pivoting allows or helps us to view data from different faces of the cube. Now let's talk about data warehouse applications. Data warehouse and data marts are used in several applications. Data mart is a subset of data warehouse. Actually, data marts are smaller in size. They are actually dedicated to specific departments of the organization. But data warehouse will be including all the data of the organizations. Data warehouse is bigger compared to the data marts. There are 3 kinds of data warehouse applications. First one is information processing. Second one is analytical processing. Third one is data mining. In case of the analytic processing, users' queries are executed. Basic statistical analysis of the data are performed. In case of analytic processing, OLAP operations like drill down, drill up, slice and dice, pivoting are performed. And in case of the data mining, hidden patterns are discovered using data mining functions like classification, prediction, clustering, association analysis, etc. Thank you.